Um, thank you, thank you. So I'm really honored to be here with my distinguished panelists. We're going to talk a little bit about security and privacy today. I hope the audience can really come away with some, like mainly three takeaways, I hope. If you're a dApp developer, what are some tools, workflows that you can do to create safer contracts? Of course, on the macro level, like what's happening in the security ecosystem that will allow for all these dApps that we're really excited to build. And yeah, what are the implications for the user? But before we get into that, I just want to give some time for everyone on the panel to introduce themselves. We can start with Dawn over here.
Hi, everyone. I'm Dawn Song. I'm a professor at UC Berkeley in computer science. And I work in security, AI, and blockchain. We also have a project called Oasis that's coming out. But today, I will mainly speak from my capacity at UC Berkeley as a professor. And we've been doing various research projects in the space, in the blockchain space, developing new technologies, both improving scalability and privacy for blockchain. So really happy to be here.
Thanks.
Great. My name is Crowley. I lead business development and partnerships for a company called Alethio. We're building an advanced analytics platform for the Ethereum public network. So I'll be talking about the importance of maintaining a transparent blockchain and empowering every participant on chain, from a casual user to a developer, to be in charge of their data and be able to make actionable insights based on the traces they leave on chain. Happy to be here.
Hi, everyone. I'm Esther. I'm co-founder of Taxa. And so we are building a trusted hardware-empowered logic layer for the entire blockchain. For every blockchain, there are the apps. And so I was a mathematical modeler, and I graduated from Stanford. So I'm really passionate about resolving big real-world problems.
OK. Hello, everyone. I'm Ronghui. I'm now an assistant professor at Columbia University in computer science department. And I worked with Professor Zhong Shao, who just gave a talk. We worked together and built this CertiK company. And we are aiming at building fully trustworthy smart contracts and blockchain ecosystems using the techniques called formal verification.
Thank you. So I think, of course, there's a lot of optimism in the space around blockchain. Hopefully, we could use this time or this discussion around security to bring some more pragmatism and talk about some of the risks. I would like to start off with what really differentiates building on the blockchain from the traditional web space. Are there new attack vectors or new concerns that a developer needs to think about when building on the blockchain? Maybe we could start with Ronghui on that side.
OK, sure. So I would say it's quite different. Well, in the blockchain world, right, most of the smart contracts and blockchain code, they are open sourced. So it means that all the attackers, they can read the source code and try to find the bugs and utilize them to do the attack. And different from traditional system, that you can only do this black box attacking. That's one thing. So it means that if there's a bug in the code, eventually they will be figured out by the attackers. That's one thing. Second thing is, well, for this, I would say that, well, now the code quality in the blockchain world is lower than the traditional software industry. We have to admit that fact, because people are too busy to write, well, comments, unit tests, and so on, and they also don't have time to do this code review and so on. So it's really vulnerable. We can see from all these attacks happen almost every week, almost every month, I would say. Yeah, so on the third one, there is a huge attack benefits that will attract more hackers to attack the system, attack the digital asset exchanges, and so on. So we really need some way to protect this blockchain world.
Does anybody want to add to that?
Oh yes, I definitely agree with his opinion. Like, I think formal verification is very important to ensure your smart contract is reliable. And I think on top of that, it's also very important to make sure your smart contracts, especially the computation part and the logical processing part, the execution part is processed in a secure and reliable environment. And that's what Taxa is doing for the blockchain.
And I'll just add, within this emerging space, there's a massive gap between the established developer core, and as we look to expand the ecosystem to newer users who have yet to really walk up that learning curve, there's a strong risk of whether it's leaving traces on-chain or acting in ways on-chain that these new users aren't entirely sure the impact that it has. So because everything you do on-chain is public, you run the risk of leaving a trace or conducting an activity on the network that someone else may be informed of that you're not. So how do you think about providing the user interface, the visualizations, the tools necessary to maintain that informed perspective? Because if we're going to hope to expand this ecosystem beyond just the developer base, you have to provide the tools to more casual users. And I think right now the challenge is that learning curve is just too steep. Personally, we're building tools to help reduce that, but I think regardless of the chain, regardless of the company, it's important to realize that you have the technical side that is running the risk of attack, but also you have a very new user base that is vulnerable as well. So how can we as a collective ecosystem provide the tools to protect the newer entrants? And I think that's important as well.
Yeah, I think from technology perspective, actually, it's very interesting in the sense that, actually, if you look at it even today, like what kind of technology are being used to help analyze smart contract security and so on. So a lot of it is traditional. From the technique itself, it's the traditional techniques that we have been doing in the software engineering and software verification field, including formal verification. You can do dynamic analysis. You can do static analysis. We actually also had some research projects earlier, actually using COC we did some of the earliest work using COC to actually provide some formal verification of smart contracts security. I think the interesting part here is that typically, when you talk about the security of, for example, a program, then there are different levels of security. There is, for example, you can talk about memory safety, that's one level. And then more at the application level, often then you need to talk about the application level security. And these are very application dependent. Some are, for example, there's access control, and there's others. That's, for example, especially in smart contract, you want to make sure that how money flows is what you want it to be. I think some of the real challenges for smart contract is actually at the application level. Of course, smart contract itself really specifies a lot of these application logic. And that's actually the same challenge that we have been facing in the traditional software engineering, software security as well. It's at the application level, how do you specify what you really want? So for example, in this case, you have a smart contract, the money is flowing, and there are certain conditions. How do you actually specify that, what you actually really want the smart contract to do? And then once you have a good specification, then there's a lot of existing traditional techniques that we can apply to address that. But I think one really big challenge for a lot of developers to really think hard about is how do you specify what you really want? And only when you understand that, then you can talk about how you prove or verify the security of the smart contract.
Yeah, here I want to maybe add a few more sentences, because in 2015, we also, I and Professor Shao, we also realized that the specification is the key bottleneck of this to the improvements of security and safety. So we introduced this deep spec concept, and was widely studied by a broader community, right, including Yale University, Princeton, MIT, UPenn. And now in the CertiK project, we introduced a so-called labeling language to help the dApps or blockchain developers to write this kind of specification to express what you really want, right, for this piece of code. And then, based upon that, starting from that, we can utilize lots of existing tools, techniques, trying to give you a pretty high guarantee. Right?
Mm-hmm. And one thing I want to just add, over the past year, we focus on Ethereum, but the network has grown immensely in size and complexity. I mean, there's almost 30 million unique addresses on the network. Last year, almost 700 ICOs launched and raised almost $5 billion. So yes, there are risks of attack at the code level externally, but as an ecosystem, we have to concern ourselves with outward-facing attacks in the form of Ponzi schemes or fraudulent token launches, for example. So these I view as attacks as well, but on newer users or newer token launch participants. So how do we put the safeguards in place that A, protect potential participants in these token launches, but also protect the ecosystem against regulators who view these fraudulent events as reflective of the entire ecosystem? Because there are a number of ICOs that are essentially pronouncing they are Ponzi schemes. But the casual investor sees an opportunity to make some money. They're being preyed upon. And I think those are just further instances of giving regulators the opportunity to kind of cite bad actors that aren't indicative of the rest of the ecosystem. So how do we, again, provide tools to clearly identify these bad actors on chain, and then also insulate those who are actually building quality on-chain applications and using the ICO as a means to fund that in a very proactive and measurable way versus a means to just raise a bunch of capital and then screw over their investors.
100%, yeah. I could see a lot of this conversation interplay together, right? Like for those of you who are investing in these token launches, if they're not properly spec'd out, the developers are not very clear about what exactly is being built, what are these platforms for, then besides the fact that they could be technically compromised, then it's a lot of not really showing a lot of value to the ecosystem. But in terms of Professor Song, I really appreciate your comment on focusing on the application layer and the security there.
And the specification.
Yeah, right, and the specifications. Maybe we can shift the conversation into that area where, given the current tool set, are there particular, given the current state of things, are there current applications that should not really be a focus? Are we not ready? I know in the Edekin paper that you were published in, you talked a little bit about how if there is something like a decentralized credit score, we need something to hide privacy for the individual. Given the current ecosystem, are there things that are not really able to be built, like applications that shouldn't be looked at?
I think overall it's more about what technologies we need to build. Right, so for example, blockchain today, many blockchains, essentially everything's public, but for a lot of applications, we need more privacy protection. So these are, for example, for financial applications, for healthcare applications. Ultimately, we want to enable lots of these really exciting applications that beyond, for example, just payments and so on. But when you go into these other even more complex applications, oftentimes you are dealing with data that's very, very sensitive. And the question is, how do you actually provide the needed privacy in the setting that can enable you both having the property you want from a blockchain, including, for example, persistency, immutability, and even transparency. Right, but on the other hand, you still get to protect the privacy of the sensitive data. And I think people are, in general, very excited about privacy, but I would say that one important thing to recognize is that privacy is a very complex topic. And when we talk about privacy, there are many different aspects of privacy. Privacy is at many different layers. So for example, you can talk about secure computation. That's to protect the computation process from leaking sensitive information. So often there are different secure computing technologies that one can leverage, including a combination of secure hardware as well as crypto-based techniques such as secure multi-party computation and other methods. And also, at the application layer, there are privacy challenges as well, in the sense that even the computation results actually can leak sensitive information about the input. So one work that we did recently is about showing that, for example, when you train a deep learning model, then for example, when the deep learning model is trained over a data set like email data sets, and the data set contains already social security numbers and credit card numbers, which are very sensitive information, then an attacker who doesn't even need to know the details of the deep learning model, but just querying this learned deep learning model, in this case it's a language model, it can actually extract the social security numbers and credit card numbers that actually included in the original training data set. So this is an example showing that when we are talking about privacy, it's a very complex topic. So in this case, when you are doing machine learning on sensitive inputs, you actually really need to think about, in this case, what does privacy mean, and how you can provide privacy. And in this case, if you are just doing secure computation, for example, it actually won't solve this problem at all. The computation process doesn't need to leak the sensitive information, but in this case, it's the trained machine learning model that actually can leak sensitive information. So I think these are really the complex privacy concepts and topics that for app developers, I think is something that they need to be aware of. And from a research perspective, our goal is to develop the technologies and the tools such that we can help app developers to solve these problems. So for example, we've developed techniques and tools for differentially private data analytics and machine learning that exactly can help solve these problems. If you train a differentially private machine learning model, then in this case, the attacker actually won't be able to extract, for example, the social security number and credit card number from the learned model if the learned model is differentially private. So we have been developing a lot of techniques and tools to achieve this type of privacy. And then some of our tools actually have been deployed at Uber in collaboration with Uber.
Awesome.
To help them to provide privacy for their data analytics. So these are just examples of the different types of techniques and tools that we are developing to help app developers such that they don't need to be experts in, for differential privacy or for secure computation, but they can leverage these techniques to build privacy-preserving applications. So that's, I think that's very important.
Yeah, I mean, that sounds very similar to some of the work that you're doing too, Ronghui.
Yeah. So I definitely agree with Professor Song that privacy is a pretty complex issue, and I want to add one more thing. Is kind of like we also want to come up with a way to specify the privacy policy such that it can be utilized by the average users. Like sometimes you don't want to leak the individual numbers, let's say in an array, but you can leak the average, right, of this array. We also want to come up with this new way to talk about this privacy policy and integrate into, for example, into the blockchain and make sure that this policy are correctly maintained, for example. So that might also be a pretty interesting topic.
Yeah, and also I want to add a few points too. So at Taxa, so our approach is actually very product-oriented and very design-oriented. So before we come up our technical stack, we actually interviewed potential clients in different industries such as fintech, cloud computing, and analytics, AI, and then we find this very abstract, high-level question is, given the increased amount of data we have today, and all the merchants actually want to take advantage of the data without losing the right, the ownership of the data. So that's essentially you want to circulate your data without losing the privacy. So to absorb this problem, our current internet infrastructure currently actually cannot do it. Right now, there are very a traditional and operational approach in the internet industry, such as they have a third-party agency who take the data from the two parties and then do the sort of analytics or AI models they want. However, the ownership is actually gone, and because the agency, you don't know what agency would do with your data and whether that kind of execution is ensured is exactly what you wanted them to do. So blockchain actually empowers this sort of use case. And so, first of all, the execution can be guaranteed. And the second, the privacy can be also guaranteed if we are introducing this new technology as a trusted hardware. We at Taxa, we believe the new technology, the new rising trends, especially in the new inventions in the hardware landscape, can dramatically and vastly change the current blockchain landscape and to empower new use cases, especially with the increased demands with the data aspects. Everyone is talking about big data, and big data has been become such a common thing in today's AI or fintech or any kind of industry. But now we think blockchain would be the one to take the data to the next level, not at the internet level, not the centralized agency take all the benefits. With blockchain, we believe like everybody, every data owner, no matter it's a small merchant or a big merchant, they can utilize this technology. And by adding powerful infrastructure to make sure the execution is ensured, also to make sure the privacy is protected. So we actually think instead of asking what kind of application shouldn't be done on blockchain, we'd love to ask what problems you think the current internet industry didn't resolve. You want the problem could be done on blockchain, and can you find a solution? So yeah, that's our approach.
Thanks, Esther.
So maybe one thing I just wanted to quickly add. One of the projects that we are doing, that's in collaboration between Berkeley and MIT, is an open source secure enclave design called Keystone. So people have heard about, so secure enclave is a technology, a type of secure hardware where you can run applications inside this secure enclave that provides isolation. So what's running inside can be protected from what's outside, so you can, so the outside, like operating systems and applications, cannot see what's running inside the secure enclave and cannot modify it. But in this case, the security of the hardware is really important. And so far, we don't really have any open source solutions. There are commercial solutions, but there's nothing open source. So we think that it's really important for the entire community to have an open source design for the secure enclave. This way we can actually leverage the whole community efforts. The whole community can together analyze and verify the security of the secure hardware so that we can ensure that we can really build truly trustworthy secure enclave. And so far we've gotten a lot of excitement from the community, and we really hope that this can be a truly a community effort that people can actually join and help. And again, it's called the Keystone Enclave. If you just go to Keystone-Enclave, you'll find the more
That's
information.
great, yeah. I know that there has already been a lot of excitement around SGX, but because it's very proprietary and Intel owns that, like, it's difficult to know. You just have to trust Intel that you're...
Right, and we don't want to do that. Right, I think. And also this leverages the existing experience and expertise from, for example, Berkeley actually has a long-term experience in doing open source hardware design. People may have heard about RISC-V, which is an open source RISC architecture that has been designed at Berkeley that now has very broad industry adoption. And so the RISC-V Foundation has over 100 members now from top industry and various institutions. And as a first step, the Keystone will be actually built on top of RISC-V. So essentially adding a secure enclave on top of this RISC-V existing open source RISC-V.
Cool.
RISC architecture.
I'd like to shift the conversation over into a bit of the, like transparency and privacy as well. And I think from Alethio's standpoint, Christian, I'd like to see, like, a lot of people fear this this transparency, whenever they think about it, that they feel like they're giving up some like visibility. I was curious, like, how you think that these tools can be used for good, how transparency could be used for.
Certainly. So at the end of the day, I mean, you're acting on the Ethereum public network. All that information is publicly available to anyone. Right now, those who have the capabilities and tools to access and kind of create a holistic profile of your on-chain behavior is a very limited set of individuals. And just to tie it back to this conversation around applications on-chain and which ones we should perhaps avoid putting on-chain, to date, we've really only seen very few meaningful utility applications on the network. We've seen a number of token economies that purport to support business models on-chain, but in reality, they're just a means to store value to a certain extent. I think we're going to see more actual business models being launched on-chain with token economies that are core to their business. And I think being able to understand current and past activity of participants on-chain is important, because on the one hand, other people can paint a portrait of your profile, your persona based on that action, and being able to provide a level playing field around transparency and visibility to anyone on chain, to level the playing field around being able to visualize and understand what an action on chain would implicate for yourself, your business, your counterparty. The ecosystem, I think, is critical to ensure those who are acting on chain do so in a way that's equitable and understandable, because right now I think the current tool set does not provide the capability for the less technical to maintain control. At Alethio, I'll just end on this piece. Our mantra is data sovereignty. So right now, everything you're putting on the network is out there for those to consume. We're providing the tools for you to at least maintain the same degree of understanding of those actions. And as the ecosystem grows in complexity with more dApps launching, that's only going to get more difficult. So we believe your tool set should evolve commensurately. So you should be evolving with your capability, and it shouldn't rely on your ability to code Solidity, for example. It should rely on your ability to access very accessible tools like Alethio.
Thanks.
Yeah, and I also want to add it as I think transparency is actually very important, and not just because the open internet concept which is encouraging everybody to build this open world. It's also because in some segments, actually transparency is essential in terms of operation and implementation, such as charity funds, and everyone heard of the scandals about those charity funds who did bad things. But what about we can leverage the blockchain technology to make sure their execution is fully transparent? I think everyone can benefit from that. And also, for example, supply chain, you need that kind of a transparency to track the entire process. And so for those segments, we definitely think fully transparency, like 100% transparency, is worthwhile, and it's necessary. But for some other parts, especially with anything comes to the data privacy or data assets, no matter it's an individual, like everyone here, your health data, your phone history, your message history, or it comes to the company who has a big stack of valuable data, then fully transparency doesn't really make sense in these terms. So we actually believe that whether you should be 100% transparent or not, it actually should be determined based on your own business attributes, what kind of a segment you're in, and what are the core functionality of your industry. Like they really matter. That's really essential for you and for you to build a sustainable business. Then you should be able to make an informed decision rather than just follow one direction.
Thanks.
I just want to add a few more sentences. Kind of like we are doing formal verification for smart contracts and so on. This procedure also needs to be transparent in the sense that it's kind of like we make everything like a black box. They just trust us because we are professors. We should make our proofs kind of like machine checkable and transparent, such that you can check the you can validate those proofs on your own machine. You don't need to trust us. That's one thing. Second thing is kind of like talk about the back to the previous topic on the privacy that Professor Song and Taxa, they emphasize the hardware, the trusted hardware, like the SGX, like some trust zone and this kind of thing. I will say they are helpful, but they are not definitely can solve all the problems. We also need to make sure that the software built on top of those trusted hardware are also operated in the correct way. And for those part, I think we still need to rely on some existing techniques like formal verification and so on.
Thank you. So we're out of time here. Thank you all for sharing your insights on privacy and security. Thank you for the time, guys. Thanks. All right. Let's go.